Hello, the objective of this video is to review some of the exponent laws. In particular, we're going to review the multiplying law when you're multiplying like bases and the divide law. When you multiply like bases, you're going to be adding the exponents that will give you the same result as multiplying the like bases. When you divide like bases, you're ending up subtracting the exponents will give you the same result. So let's take a look at some examples. Okay, here's an example where we have 2 squared being multiplied by 2 to the 5th power. Now to work this out, you would normally take the 2 squared and expand it out to make it 2 times 2. 2 to the 5th would expand out to be 2 times 2 times 2 times 2 times 2, 5 2's. Now when you go to multiply all these together, you notice that you have 1, 2, 3, 4, 5, 6, 7 2's being multiplied. So this is the same as saying 2 to the 7th power. Well, looking at the exponents here, we have a 2 and a 5. Isn't it funny that those two added together are going to give you a 7? So yeah, as it works out, if we take those exponents, 2 plus 5, and we add them together here, we end up getting 2 to the 7th, which is what 2 squared times 2 to the 5th is 2 to the 7th power. Okay, so here we have an example with a variable instead of with numbers. Now, when you work this one out, x to the 5th would be x times x times x times x. This is going to be a whole lot of x's, isn't it? Well, this would be a lot easier if we work with our adding of exponents. We take the same base, and we're going to add the exponent of 5 to the exponent of 7 to this exponent. But there doesn't appear to be an exponent here. Remember, it's understood when there is no exponent there, it's understood to have an exponent of 1. So we are going to be adding those together. We end up getting x to the 5 plus 7 plus 1, which is going to give us x to the 13th power, which is our simplified version of this expression. This would be the simplified answer. Now down here we've got a combination. We have some 2 bases, we have some 3 bases. Now, if we were to write these out, this would be 2 times 2 times 2 times 2 times 2, 2 to the 3rd. And then we'd have times 3 times 3 times 3 times 3, that would be 3 to the 4th. And then we'd have that times 3 squared, which is 3 times 3. Now, we cannot combine the 2's and 3's here. These are not like bases. 2 times 2 times 2 times 2 times 2 does give me 2 to the 5th power, but I cannot combine that with these 3's because it's not the same base. When I count these up, I end up getting 3 to the 6th power. So this is as simplified as this expression gets. You can only add the exponents of like bases being multiplied. Okay, let's look at dividing. Here we have 3 to the 5th divided by 3 squared. And expanding it out, that'd be 3 times 3 times 3 times 3 times 3, 3 to the 5th, over 3 times 3. Now you remember when you were simplifying fractions, if you had a common factor in both the numerator and denominator, you could cancel them out. So these 3's would cancel, these 3's would cancel, and you'd be left with just these, which means that this is going to be equal to 3 times 3 times 3. Well, over what? Well, this would simplify to just 1. Remember, when everything canceled out on the bottom, it became a 1. So I could write it over 1 over here, but it's not absolutely necessary. In fact, it's just clutter. So 3 times 3 times 3 is going to give me 3 to the third power. And that would be my simplified answer for the division problem here. To simplify it completely, since we do have numbers, we would actually do the 3 times 3 times 3, which would give you a 27. But that's if they're asking for it to be simplified completely. This would be the simplified using exponents. All right, for the next one here, now notice how this was 3 to 5, and this was 3 squared. How would I get that 3 from the 5 and the 2? Well, 5 minus 2 does give you 3. Now if you look at this, for each one I had, I was canceling, I was taking it away. If I take away every one on the bottom for every one that I have on the top, to take away from the top every one that I have on the bottom, 5 minus 2 is going to give me 3. So the rule for division, the exponent rule for division, says that when I'm dividing like bases, I can subtract the exponents. So this is going to become x to the 9 minus 3, which gives you x to the 6th power. 3 of the 9 x's up here are going to be canceled out by the 3 down here, which is why we're subtracting the 3, and the result will be x to the 6th power. Okay, here's a you do. I'd like you to pause the video and try these problems on your own. I'll give you an answer in a minute. Go ahead and try them. All right. Welcome back. The answers here are 3, this one's going to be equal to 3 to the 16th power. This will be x to the 13th power, adding the 2 exponents there. This, yes, you have to rearrange things a bit because the x's are on both sides here, but the commutative property of multiplication says you can change that order. When you do that, you end up with x to the 7th times y to the 8th. And there's your answers for these. Okay, here's some you-dos with division. Pause the video and try these two. Welcome back. All right, now these are going to work out to be y to the 7th minus 3, which is going to give you y to the 4th power. This is going to be a to the 4 minus 7, which is going to give you a to the negative 3. But we should know that a negative exponent is not a simplified answer. To simplify it completely, we would want to make that a positive exponent. And to do that, well, think about this here. If you have 4 on top and 7 on the bottom, these 4 are going to cancel out, leaving you with 3 on the bottom. So it kind of makes sense that this would be equal to 1 over a to the positive 3. To sum up, we have, whenever you're multiplying like bases, you add the exponents. When you're dividing like bases, you subtract the exponents. Thank you for watching.